Hello students. So now in this lecture we're gonna see a very important chapter, a fresh chapter from Max 2, that is chapter number 3, linear regression. So now in this chapter there are three exercises. As your first exercise, it is based on regression equation. It is based on regression equation. So we'll consider the first exercise as type number 1. Second exercise as a type number 2, and third exercise as a type number 3. So we'll give this exercise number first as type number 1. So instead of saying exercise, I will say type. Okay. So now in the type number 1, we'll see how to find the regression equation. As here we have two regressions of equation. One is y on x and second one is x on y. So this is the actual formula. This is the actual formula. This is for y on x and this is for x on y. So here now we'll see what do you mean by y on x and what is the meaning of x and y. It means y on x means in simple language I will explain. Y on x means y is dependent. Y is known as what? Dependent variable. So here we can say this y is what? Dependent variable, and x we can say it is independent. So in simple language it means y is depend on x. Y is depend on x. If you have the value of x, then only we can find the value of y. So that's why in y on x, y is known as dependent variable and x is known as what? Independent variable. Independent variable. It means when you have the value of x, then only we can find the value of y. Or else you can remember this y on x like this also. Y on x means y means to find. Remember as to find, and x means given. It means when you have the value of x, then you have to find y. So I hope you got understood what do you mean by y on x. So y on x means actually in the professional language y is known as dependent and x is known as independent. That means y, when we have the value of x, then we can find the value of y. Okay, so you can remember like this or this one also. In case of x on y, here x will be what? Dependent variable and y will be what? Independent variable. Yes, in simple language we can say that here x stand for what? To find, and y will be what? Given. It means when we have to find the regression equation x on y, that means you will have the value of y, you have to find x. Or else you can remember like this also. Y on x means what? Y will be on the left hand side. This dependent variable will be on the left hand side, and the remaining numbers and the independent variable, that means x, will be on the right hand side. Y will be on the left hand side and the remaining numbers and the alphabet, that means independent variable, that means x, will be on the right hand side. So this is known as y on x. X on y means what? X will be on the left hand side and the numbers and this y will be on right hand side. So this is known as x on y. So there are 2-3 ways in which you can remember y on x and x on y. Okay, so now this is the actual formula to find y on x, and this is for x on y. So now we'll see what is the formula here. So here the formula is y, this is capital Y, okay, equals to a small a plus b y x, okay, b y x capital X. So this is known as a regression equation of line y on x. So this is y on x. Okay. So first we'll see the concept for y on x. Then after that x on y. So this is the formula for regression of y on x, regression equation of y on x. Okay. So that means when you will write the formula, you must have the value of a and b y x. So here we have the formula for a also, small a. It is y, okay, bar, yeah, we can say y dash minus b y x x dash. Now we'll see here what is the meaning of y dash and x dash. This x dash and y dash, actually it is known as mean. This is x mean, we can read this as x mean and this as y mean. So we know that mean means what? Mean means what? It is average. Yes or no? So average of x upon total number n. So this is the formula for x mean. So x mean is what? Total of xi upon n, and y mean will be what? Total of yi upon n. So here n is what? Here n is the number of observation. N is what? Number of observation, or else we can say number of row. Okay. Your question will be in this form. You will have the value of x and y. You will consider this x as xi and y, capital Y, as yi. Then after that you will construct a table. Okay. So here we'll see the number, that means how many rows are there. So here clearly we can see that 1, 2, 3, 4, 5. So there are 5 number of rows, so we can say the value of n is 5, or else we can clearly see that the number of observation in x and y, 1, 2, 3, 4, 5, and in y also there is 1, 2, 3, 4, 5. So from this we can find the value of n. Understood? Okay. So total of xi. So this is your xi, this is your xi, and this is what? Yi. Total means total of this part xi and total of yi. So total of xi upon n, you will get x mean, and total of yi upon n, you will get y mean. So after finding the value of x mean, y mean, you will substitute the value of x mean and y mean here. Okay. Understood? Now, so here we got x mean and y mean. Now we have to find byx. So here what do you mean by byx? We'll see now. Here byx is known as a regression coefficient. Now remember this, byx is known as coefficient, regression coefficient, and this equation is known as a regression equation. As we all know that the chapter name is what? Linear. Why it is linear? When you will see the equation, the power of the variable, as it is straight, the equation is straight, and the power of the variable x and y, okay, the dependent and independent variable, the power is what? 1. Can you see the power of x and y? It is 1. So that's why this is known as what? Linear. And this is a equation. Why it is equation? Because here equal to symbol is there, and this equation is known as a regression equation, y on x, and this is known as x on y. Okay. So now After that we have to find byx. So here byx is known as what? A regression coefficient. Remember, there is huge difference between coefficient and equation. So here we have to find coefficient. When you will see, as there are three formulas for byx. Now the question will rise that, sir, which formula we have to use? First, second, or third? Now listen carefully. First and third, actually it is one and the same. Both are same only. When you will apply the first and third, what you will see that in both the cases you will get the same answer. Even when you apply the second formula also, you will get the same answer only. But remember, here some points I will say that you have to remember. Apply the first and third formula when the values are smaller. When the values are smaller value. This also I will write smaller value. Apply the second formula when the values are larger. When the values are larger. So now, sir, what do you mean by smaller and larger value? When you will see the question, you will have the value of x and y. Here clearly we can see that the value of x and y is 1, 2, 3 single digit. Yes or no? Double digit is also there, 11 and 13. Remember, for us in this chapter, the smaller value is till 30 and larger value start from 31. Why I am saying like that? After 30 it is the larger value and less than 30 is the smaller. As you will write xi and yi. After that you will find the square of xi and then yi. As I hope you all might be knowing the square till 30. Yes or no? 30 square is 900. After the 31, 32, I guess you all might not be knowing. So I hope you all might be knowing the square till 30. So, and it is compulsory that you have to buy it the square till 30. 1 to 30. Okay, so remember like this, if the values is less than 30, consider as a smaller value. If the value is more than 30, consider the values as larger. So whenever the values are larger, like it is 50, 60, more than 100, so straight away apply the second formula. Whenever the values are smaller, apply the first and third formula. Okay. So in first and third also, sir, which one will apply? First or third? I will suggest apply the first one. You can apply the third one also. So then when we have to apply the third one, sir, you can apply the third one also, no problem. When you will apply the first and third, in both the cases you will get the same answer, no difference. But remember, apply the third one when you have the ready-made values. That means you have this ready-made values of x mean, y mean, then apply this third formula. Or else, whenever the pattern of the question is like this in the form of x and y, when you have x and y, when you have this ready-made value, then apply the third one. Understood? Okay. Now once again I will explain. So here for byx there are three formulas. You can apply the first and third to get the answer. So remember, apply the first and third for the smaller values and the second formula as for the larger value. So here consider when the values are more than 30, consider as a larger value. If the values are less than 30, consider as smaller values. Okay. Now when you will see the difference here, a regression coefficient of y on x and x on y, clearly we can see that the numerator part, can you see the numerator section? For both the cases it is same. Numerator same, numerator same, numerator same. So here what is the difference? What is the change? When you will focus on the denominator is different. Here it is x, x, x. On the other side it is y, y, y. So here remember like this, when you have to find y on x, the pressure is on x, y on x, y on x, the pressure is on x, so x will come in the denominator. When you have to find x on y, so here the pressure is on y, so y will come in the denominator. So remember like this, okay? Here also for x on y, when you will find bxy, first and third, first and third, okay, first and third, you will apply for the smaller values when the values are smaller, okay, and second one for the larger, okay. So for the second on x and y also, first and third for the smaller and middle one for the larger, or else we can say the third one for the ready-made values also. Whenever you have this ready-made value, okay, straight away substitute the value, you will get the answer. Okay, so now here we got the idea how to find byx. So for byx there are three formulas, okay. So in both the cases the numerator section is same, okay. Changes what? The denominator. So remember, whenever it is y on x, x it is on pressure, okay. Y on x means the pressure is on x, so that means x will come in the denominator. X on y, x on y, so pressure is on y, so y will come in the denominator. Can you see y, everywhere there is y only. Whenever it is y on x, x will come, okay. Got the point? Okay, so now after applying this formula you will get the answer, okay. You will substitute the value here in byx. So we have the value of x mean also, y mean also, and byx also. You will substitute the value of y mean, byx, and x mean, you will get the value of a. After that you will write the regression equation of y on x, where you will substitute the value of a and byx, okay. Assume that here the value of a is 2 and the value of byx is something 0.25 or 3 will take, okay. So replace the value. Suppose the value of a is 2 and byx is 3. So here clearly we can say that it is a equation. Why it is equation? As here equal to is there. It is a linear regression equation because the variable, the power of the variable here it is what? 1. And on the left hand side here it is y, and on the right hand side it is x. So this is known as y on x. If x is there on the left hand side and y is there on the right hand side, y and number, x and number, okay. When y is there on the left hand side, that means y on x. When x is there on the left hand side, it is x on y. Understood? So in this way you have to find your answer, okay. So here also when you will find on x on y, here we have the formula for regression equation of x and y, okay. Here also first you will find a dash, so x bar minus b xy y bar. As we know that first we'll find x mean and y mean, okay. So for x mean the formula is total of xi upon n, for this is total of yi upon n, and we know that it is number of observation, yes sir. After that we'll find bxy. For bxy there are three formulas, as we know that first and third you will apply when the values are smaller, when the values of x and y are smaller. Okay, consider above 30 larger value, below 30 smaller values. Okay, and second formula you will apply when the values of x and y is larger. Okay, got the point? After that, after getting all the three values, you will substitute the value where you will get a dash. Okay, then you will take the regression equation x on y. You will substitute the value of a and bxy. We'll assume this a dash as 2 and bxy as 3. Okay, so here clearly we can see that it is an equation, it is a linear regression equation, as the power of the variable is what? 1. And why it is x on y? Because left hand side clearly we can see on the left hand side x is there, and on the right hand side y and number is there. Understood? Got the point? If on the left hand side y is there and on the right hand side x and number is there, so it is known as y on x. Got the point? Understood? Okay, so as I had explained everything about y on x and x on y, how to remember what is y and what is x and what is y on x, yes or no, and what is x on y. Okay, then we saw how to find x mean, y mean and the value of n from the given question, and this is the main formula, main section we can say. We can say the second last step where you will write the formula, you will substitute the value of a and b yx. So the first thing what you will find a, and the next thing what you will find byx. So to find a, here we have one formula. To find byx, we have three formulas. Here also same. First we'll find a dash, after that we'll find bxy. So for bxy there are three formulas. Understood? Okay, now this is what, when you will substitute this value of a here, as a is what, y mean minus byx x mean. When you will substitute the value of a here, okay, rearrange this, shift, okay, shifting or rearranging, you will get this answer. Okay, so either you can apply this formula or this one. In both the cases you will get the same answer, and both are known as regression equation of y on x. This is also y on x. Clearly we can see that it is y on x because on the left hand side y is there and on the right hand side x is there. But I will suggest to solve the sums of first exercise, each and every sum, by this two formula. This formula you apply for the ready-made values, ready-made. Okay, here also this one also for ready-made. Okay, understood? Okay, so now the third formula is common for both. This is small r. The small r is known as coefficient of correlation. The chapter name is regression. Okay, and this is correlation. Small r stand for correlation. So for correlation, here we have plus minus square root of byx and bxy. Yes or no? Bxy, we can find bxy by using three formulas. Okay, and bxy also by using three formulas. So basically this third formula you will apply when you have the ready-made values of byx or bxy, or else after solving this part you will get the answer. Substitute the value of byx and bxy, you will get the answer. Now remember, if byx and bxy, here the value of r, either it will be positive or it will be negative. So now how to guess whether it will be positive or it will be negative? If both the values of byx and bxy are positive, then r is positive. If both the values of byx and bxy are negative, then r is negative. If in case you are getting byx positive and byx positive and bxy negative, so straight away you have to think that your answer is wrong. As per the rule, the value of byx and bxy, the symbol should be same. Either both should be same symbol, positive, or both should be negative. It cannot happen the value of byx negative and this part will be positive, or vice versa, positive negative. In case if you are getting like this, straight away you have to think that your calculation part is wrong, your sum is wrong, because this plus minus means what? Either the answer will be r will be positive or it will be negative. When both are positive, straight away you will say that the value of r is positive. When both are negative, the value of r will be what? Negative. Understood? Now, as this was the theory part which I was explaining each and everything, okay, so when you will solve 1 or 2 sums based on this, so you will come to know exactly how to apply the formula, how to substitute the value, and how to find the final answer, that is a regression equation y on x and x on y. So here we'll take 2 example, one based on smaller value and one based on larger value. Okay, as I told, first and third formula you can apply for the smaller. In both the cases you will get the same answer, but I will suggest to apply the first formula for each and every sum. What about the third one? When you have the ready-made value of x mean, y mean, this all if you have the ready-made values, or as okay, now here I forgot to explain what is COV. COV is known as covariance. It is known as covariance, and VAR is known as variance. It is known as what? Variance. It is known as what? Variance. Okay. So this symbol, it is not exactly C. It is not 6 actually. It look like 6 when you will say like this. Okay. Actually, it is a Greek letter, lower case. In a Greek letter, we write this the lower case as, it look like 6. Actually, it is not 6. This symbol is known as sigma. As you will say that, sir, we know that for sigma it is like this. Okay, this is lowercase Greek letter. Okay, so here the meaning of this symbol and this symbol both are same. It is known as sigma. That means total, we can say. Understood? So this symbol is actually known as standard deviation. Standard deviation. In short, we can say ST. Standard deviation. In short, we can say SG. So when you write this as square, so this become variance. This becomes variance. If you write here x in the base, this is variance of x. If you write y, okay, in base, so that will be variance of y. So remember, this is COV known as covariance. Covariance means what? This numerator part is known as covariance, and variance means what? The symbol is known as what? Standard deviation. When you square this part, square of the standard deviation, when you write standard deviation square, it is known as variance. When you write x on the base, it is variance of x. When you write y on the base, it becomes variance of y. Okay, so remember this small things. So this was, I can say, a concept based on a regression equation y on x, and this side it was x on y. Okay, remember the numerator part, it is same for both the cases. Change is the denominator part. You can remember like this: y on x, pressure is on x, x will come in the denominator. X on y, pressure is on y, so y will come on in the denominator. Understood? Okay. So in short, I will say that you have to solve whenever the value is smaller. Whenever the value is smaller. Okay. Whenever the value is smaller, I will suggest to apply this formula and the first one. For x and y, this one and the first one. Understood? Okay. Second for the larger. So we'll take two example, one based on smaller and one based on larger. So let's take one example based on y on x as well as x on y for a smaller value. Now we'll take one sum based on the smaller value, where we'll find the regression of equation for both the lines y on x as well as x on y also. Okay. Now, but in the exam they will ask only one part, either y on x or else x on y. And remember, each and every sum of your first exercise, that means your type number 1, that is of 4 marks. Okay. So we'll take one example where we'll see that when the values are smaller, and one example where the values are larger. Okay. So in this sum, we're gonna solve both the section y on x as well as x on y also. But remember, in the board exam, either they will say to find y on x or else x on y, not both. So here already I had calculated each and everything, each and every column. So remember this, you will have capital X and capital Y in the question. First step, you will write let capital X be xi, small capital Y be yi. So your first column will be xi, second will be yi, third xi square, fourth yi square, and fifth xi yi. As you will have the value of x and y, the third column is xi square, so that means the square of the first column. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. yi square, square of the second column, 5 square is 25, 7 is 49, 9 81, 11 121, 13 169. After that, you have to multiply xi yi, first and second column. 5 ones are 5, 2 sevens are 14, 3 nines are 27, 4 elevens are 44, 5 13s are 65. After that, you will add these numbers 1 2 3 4 5, where you will get 15. So this 15 is what? Total of xi. When you will add the second column, you will get 45, third 55, here I got 55, 445, and the next 155. After that, you will write this step from the table. We have n, so here n is what? Number of observation. We can say number of rows, 1 2 3 4 and 5. A number of observation in x and y. So in x, 1 2 3 4 5 numbers are there, and y also there are 5 numbers, so n is what? 5. So you will write the total of xi is 15, yi is 45, xi square is 55, yi square is 445, and xi yi total is 155. After that, you will find x mean and y mean. As the total of xi is what? 15. N is what? 5. So 5 ones are 5. How much? 3. Yes or no? Yi total is what? 45. N is what? 5. 5 ones are 5. 9s are. Okay. So first we'll see regression equation y on x. After that we'll find x on y. So for y on x, this is the formula. Yes or no? Y equal to a plus by x, capital X. Yes or no? Without knowing the value of a and b y x, we cannot find the regression equation y on x. Yes or no? So that means we have to find a and b y x. So first we'll find b y x. So here b y x is what? It is known as coefficient of regression. Yes or no? So first we'll find b by x. For b by x, as we know that there are three formulas. So while explaining, I told to apply the first one, yes or no, and the second one for the larger value. So we'll apply the first formula. So the first formula is what? Total of xi yi minus n into x mean into y mean. So that means total of xi yi. So here clearly we can say the total is 155 minus n is what? 5. X mean just now we got that is 3. Y mean 9. Yes sir. Xi square, total of xi square is 55 minus n is 5. X mean square, this is mean, x mean. So here we have the mean x mean. Okay. So x mean is what? 3. So square of mean. So 3 square is what? 9. Yes or no? Remember this, we cannot cancel this 5, 5, 9, 9 because here the main connection is minus. So we cannot cancel this 5 and 9. Remember, okay? So we'll multiply this part. We'll keep this 155 same. 5 into 3 that is 15. 15 9s is 135. We'll keep this 55 same. 5 9s that is 45. 155 minus 135 20. 55 minus 45 10. When you will solve this part you will get 2. So here we got byx as 2. Remember, sometime what will happen, here directly we got the value of byx is 2. Remember here, sometime you will get the answer in decimal and you will find the byx till up to we can say 4 decimal place. But for this sum here directly we got the answer 2. So in some cases, in some sums, you will see that the answer will be in decimal form. So up to 4 decimal place you have to find your answer. Remember this, okay? After that, so here we got byx that is 2, x will be same, yes or no? So now we'll find a. So for a, we have the formula, yes or no? That is y mean minus byx x mean. So a, y mean. So y mean is what? 9 minus byx is 2. Just now we got. X mean. X mean is what? 3. 9 minus 2, 3 side is 6. 9 minus 6 is 3. So here we got the value of a also. So instead of this formula, we can apply this formula also. Still you will get the same answer as now we will get after substituting the value of a. So here a is what? 3. So this we can say it is a required regression equation y on x. Understood? Okay. So here we can say required regression equation y on x. Okay, so why it is a regression equation, as here we have equal to, it is also known as regression equation of line. So this is known as equation of line. It is a linear, it is a equation because the variable, the power of the variable here, it is what? 1. So this is the answer for y on x. Yes or no? So what is the answer? That is capital Y, we can say 3 plus 2x. So this is y on x. Why it is y on x? Because on the left hand side here we have y, and on the right hand side we have numbers and alphabet. Yes or no? And on the left hand side here we have y. Numbers and alphabet means what? X. Got the point? So that's why it is known as y on x regression. Understood? Okay, so in this way you will find your answer. Now we'll take the same sum. So now we'll find the answer for x on y. But remember, in the board exam, either they will tell to find y on x or else x on y, not both. Okay, so as here we have the formula, that is x equals to a dash plus bxy y. So first we'll find, without knowing the value of a dash and bxy, we can find our regression equation x on y. So first we'll find bxy. So here bxy, x on y, so pressure is on y, so that's why in the denominator y is there. Y on x, x is there in the denominator. Okay, so remember like this, as the numerator part for both the section it is same only. Yes or no? So now to substitute the value, total of xi yi. So here the total of xi y is what? 155 minus n phi, x mean 3, y mean 9. So 3 into 9. Yes or no? Total of yi square. Yi square is what? 445 minus n is what? 5. Y mean square. Y mean is what? 9. So 9 square is what? 81. So 155. Again same, we cannot cancel this 5 and 9 ones are 9 nines. I understood, as the main connection is minus here. We cannot cancel this part. Okay, these are the basic things. So this will be about 135 when you will multiply 5 into 3 into 9. Okay, so this 445 will be same. 81 5 is 405. So 155 minus 135, you will get 20, and 445 minus 405, so this will be what? 0, and so we're left with 40. 0 0 cancel, 2 ones are 2 twos are, so 1 by 2 means what? 0.5. So here also we are getting the direct value, that is 0.5. Okay, one decimal place only. So here we got bxy is 0.5. In some case, in some sums, you will see that when you will divide up to 4 decimal place, you have to take. But for this sum here we got directly as 0.5 only. Okay, after that you will find a dash, as x mean is what? X mean is what? 3. Y mean is what? 9. So 3, here we got 0.5 is 9. So 3 minus, so this, when you will multiply 0.5 into 9, you will get 4.5. Further you will get minus 1.5. 3 minus 4.5 is minus 1.5. And the final step, you will substitute the value of a dash, that is minus 1.5, plus bxy is what? 0.5, y. So this is what our required, we can say, regression equation is the required regression equation x on y. Why it is x on y? Clearly we can see that on the left hand side x is there, and on the right hand side number and y is there. So that's why it is x on y. So in this way you will find your answer for y on x and x on y. So one more time I will explain simply what you have to do. So this is the sum based on for the smaller values. We'll take one more sum based on a larger value. The pattern and the solving part will be different for the larger value. So here for x and y on x, what you will do, first you will construct the table. See to that in the first column you will write x I, then second y I. So first you will write let capital X be xi, capital Y be yi. Then after that xi square yi square, and in the last column xi yi. From the table you will get these values, total of xi yi, so that all the part you will write here. N is what? Number of observation. First you will start with finding x mean and y mean. Okay, when the sum it is based on to find two regression line. Two means both y on x, x on y. So first you will find y on x, then after that you will find x on y. So as here we have this formula, you can apply this one also, but I will suggest to apply this two formula for each and every sum when the values of x and y's are smaller. Okay, remember. And first formula for b y x, here also first formula for b x y, and this part don't apply this one for the ready-made values. Okay, so after that first you will find b by x, then after that you will find a, take both the value, substitute in the regression equation y and x, so you will get the required equation, regression equation, that is y on x. Understood? Y on x means on the left hand side y will be there, on the right hand side number and x will be there. After that you will find x on y. Okay, and this was the concept for your first exercise. So we'll consider the first exercise as type number 1, the second exercise as a type number 2, and the third exercise as a type number 3. I hope so you all understood how to frame, how to present, how to apply the formula, which formula, when we have to apply each and everything. I hope you all understood. Okay, there are many sums based on the smaller value in the first exercise. Okay, clearly we can see that when the values are less than 30, remember, consider the sums as a smaller value, apply this formula. When the values are more than 30, consider as a larger value. Simple. In this way you can guess your sum for the smaller and the larger. Understood? Got the point? Okay, so one more thing I just want to explain. In the question, if this is that you have to find y on x, only y on x, y on x, so that time, okay, you will construct your table with respect to xi yi xi square xi yi. Okay, no need of showing the table, that means the column number 4th y square when you have to find y on x. Remember this. So remember, whenever you have to find y on x, this table is for both x on y, y on x. Okay, but in the exercise, the majority of the sum, it is based on y on x only. I can say out of 10, 6 to 7 sum it is based on y on x. 2 3 sum, just 2 3 sum, it is based on x on y. So remember this. So y on x, simply you will find the values for xi, yi, xi square and xi, yi. So this will be the construction part for y on x, and this will be what for x on y. Okay, so here no need of finding yi square, and here no need of finding xi square. Okay, in case if they say that you have to find both, that means two regression, both the equations, so that time you will show each and every column. Understood? This is for each and every column, only for when you have to find both y on x and x on y. Simply you have to find y on x, so no need of showing the column yx square. When you have to find x on y, no need of showing the column xi square. Remember these points. Okay, so here I can say that's the end of the type number 1, that is a regression equation based on y on x and x on y for the smaller value. Remember, for the smaller. Okay, in the next lecture we'll take one example based on the larger value. Till then, goodbye.